Hi guys. We'll give it a minute and then we'll start. How you guys doing this morning? Yeah, I'm a bit tired too. It's also really dark. Not as dark right now as it was. My first class was at 8 o'clock this morning, and it was really dark at 8 o'clock this morning. Very surprising. So I'll talk just for a minute before I get started. I noticed going back over my notes that there were some things that I missed on chapter 2.4. Chapter 2.4 has a whole section on there about doing transformations, rotations, reflections, and stuff that are not centered at the origin. They're called affine transformations. And I realized that I missed it. So I'm going to backtrack. You know, we have been moving on to higher chapter sections, but I'm going to backtrack. And I want to go back over today and talk about the chapter 2.4 material that I missed, which I called chapter 2.4 part 2. I put up lecture examples onto our module for this week called chapter 2.4 part 2. If you wanted to quick print them out, or you can print them out later and copy them down. Anyway, these are where we're going to be doing our affine transformations. So I want to spend some time on that. And then I'll go back to the classwork problems that I said, don't worry, we'll get to those later. And now we're going to be able to get to them. So today I'm actually going to take a step back and fix what I had forgotten and then go back over 2.4. Okay, so this is chapter 2.4 again. And we're doing what we now have forgotten, which is called affine transformations. This is chapter 2.4, and I'll write part 2 in parentheses. Okay, so affine transformations are what we're going to talk about today. Okay, so let's take a look. I'm going to write this down too so we can have it. But so far, we've been talking about all sorts of transformations, right? So, so far, our transformations. And when I say transformations, like we're talking about reflections, we're talking about rotations, we're talking about projections, things like that, right? All the transformations that we've done have been linear. Which means that the thing that we're transforming around, right, that I'm trying to reflect across a line, I'm trying to rotate around the plane, I'm trying to project onto a plane and project onto a line, all of those things, that line, those planes, all those things have been passing through the origin. The thing we are transforming around like our lines and our planes, things like that, have passed through the origin, right? So like when we did, right, I had a line that did this, remember, and I said, oh, the line is forming an angle and I want to reflect this point across this line, that kind of thing. Well, now affine, so this is a linear transformation. Now affine transformations, they're slightly different. They have a linear component and they have an affine transformation, translation. So these are closely related. The linear transforms, right? And they're closely related like this. So like my affine, I'll call this would have been like a linear transform, right? So my affine transform is going to be a linear portion and then plus some point. And this is our affine. I always think about this as my mx plus b, right? This is like my y equals mx plus b. mx is just that slope, it's just that line that goes right through the origin, and m tells us like how steep or how shallow that equation is. B is our y-intercept, right? So when it goes through the origin, b is equal to 0. So it's just y equals mx. That's linear, right? But now if we're going to include this shift, so it's y equals 2x plus 1, right? I've got this slope of the line, and my y-intercept is equal to 1, right? So it looks like, right? So now I have a line, it doesn't pass through the origin anymore. So I got to be, checking that it doesn't pass through the origin. So I've got this point that maybe I want to reflect across this line, but the line doesn't go through the origin. So how do I need to do that, right? So I need to think about how I'm going to work it. Well, there are steps that we're going to follow. It's going to sound more complicated than it is. You'll see when we actually work it through. So what we do is we shift our world, like our axis, so that we reorient the origin. So it's almost like I say, I'm going to shift my world. So this point right here, it's right up there instead of at 0, right? I need to shift up my origin by this amount. So I'm going to shift it up. So I now have a new origin right here. And then I'm going to do my transformation, right? Everything that I do, all my points, all this stuff gets shifted up as well. So everything gets moved up. So my axis, my whole coordinate system gets moved to accommodate it so that this is normal. Now I'm going to rotate it, and then I'm going to shift it back down again, back down to normal. So that we reorient the origin. It's kind of like, I'm going to write this in slang. So I'm going to pretend that the line or the plane or whatever object that we're transforming around, etc., goes through the origin. I say make pretend. There's an actual way to actually make this work, but I'm kind of like trying to write it in regular person speak. So we shift our whole world. So our origin is now here, right? Then we do our transformation as though it were linear. So we're linear, right? And then we shift our world back. Our axis. This sounds way more complicated. It really isn't. We're going to talk about how we actually do it. Not as bad. So I'll write that in green. Not as bad as it sounds. Okay, so we're going to work it through and you'll be able to see what it looks like. Okay, and we're going to work it through with examples so you can see what it looks like, what I'm talking about. What do I mean by shifting the origin? You'll see. If you guys don't have this printed out, which you probably weren't expecting to print it out, I have it here, and then you can follow along. So I'll also scan it in later too. So example 1, find the reflection of the unit sphere centered at the origin in the plane x plus 2z equals 4. There's a bunch of things that I need to think about. So here's the thing that I'm going to be transforming around, right? So I've got this sphere and I have a plane and I want to reflect this sphere in this plane. Okay, so that's what I want to be able to do. But the plane doesn't go through the origin anymore. So the first thing I'm going to check is I'm going to just do a quick check. Check to see if the plane, I'm checking to see if the plane, because that's what remember, if I'm transforming around a plane, I had to come up with the matrix of transformation that's related to that plane. So I need to check to see if the plane goes through the origin. So that's way to see that is the point. This is a sphere, it's in 3D, so this is an R3. 0, 0, 0 is the point 0, 0, 0 on the plane. Easiest way to see if it goes to the origin is to see if the origin's a point on the plane. So I'm going to plug it in. So 0 for x plus 0 for y. Y isn't on there, but 2 times 0 equals 4. So I'm going to get 0 equals 4. No. 0, 0, 0. Not a point on the plane. So therefore, that means that the transformation that we're doing is going to be affine. Transformation will be affine, not linear. Remember, affine is a linear portion plus a translation, right? So it's the translation that we use to help shift our world. Okay, so this is the steps to shift our world, step 2. So, but actually step 2 is still a little bit of a pre-check. I'm going to decompose my origins, my sphere stuff. So this is about the sphere. So to reflect the sphere, I'm just going to reflect the center point of my unit sphere and then rebuild sphere later. We're going to actually draw this whole picture after we're done so we can see what it looks like. But let's see. So it says unit sphere. So when they say it's a unit sphere, that means that our radius is equal to 1 unit. Okay. If it's centered at the origin, that means our center point is equal to 0, 0, 0. And we just said 0, 0, 0 is not on the plane, right? And our plane doesn't go through the origin, but our sphere is centered at the origin. But the sphere is the thing that I'm reflecting. Everything I do is transforming around this plane. So I need to think about, this is the point that I need to adjust, okay? That I need to move. So the equation for my sphere currently is, remember, it's x minus 0 squared, so x squared, plus y minus 0 squared plus z minus 0 squared equals 1. This is our current. Okay, this is our current unit sphere centered at the origins, what it looks like. Okay, so let's see. So my third step, this is actually where I'm going to begin my transformation. Okay, so let's write it down. Put a little line there because now we're actually going to start our whole transformation. So since the plane does not go through the origin, we need to find a point on the plane, and I can find any point I want. I need some reference point. This is a reference point, right? Because what I'm going to do is that reference point is going to help me move the origin up to that spot. This will be our shifting of our world, our shift amount. Okay, so, you know, keep it easy for yourself, right? X equals 0, y equals 0, solve for z, you know, or in this case, I can't solve for y. I can say y equals 0, z equals 0, solve for x. It doesn't matter how you choose this point, okay, but just keep it simple. Don't stress yourself out about it. So let's write down our plane equation. So this is x plus 2z equals 4. Remember, you're getting in the habit of writing your z's with a line through them. So I don't look at it and think x plus 22, what's that? Okay, so x plus z equals 4. So what I'm going to say is I'm going to set x equals 0, y equals 0, and I'm going to solve for z. Right, so if x is equal to 0, y equals 0, I'm going to get 2z equals 4, z equals 2. Be careful, right? So now the point is going to be 0, 0, 2. That's why I said, even though y isn't in my equation, I still need to set that y equals 0 as a point. All right. Okay. Now, this is the amount that we're going to shift our world by. Okay. So we're going to shift our world by subtracting 0, 0, 2, this point right here. We're going to shift it from, we're going to subtract that from our center, right? Because I'm going to shift everything up by 0, 0, 2, okay? So that the plane x plus 2z equals 4 is now x plus 2z equals 0. Right? If I do this and I check my origin, 0, 0, 0, it's going to be on the plane, 0 equals 0. It'll be true. So this is what we want. So that what we're really doing is we're saying our origin point is moved from 0, 0, 0, 2, 0, 0, minus 2. So watch what that means, right? By doing this, right? I'm going to go 0, 0, 0, minus 0, 0, 2. Okay. 0 minus 0. Okay. 0 minus 0, 0 minus 2. That's where I got this from. So this is my new origin point. Okay. So I've got, you know, this plane equation. I've got my sphere. I've shifted everything so that my origin point is down here. Okay. All right. Our next thing that we're trying to do. Okay. We did this plane before, so I'm not going to derive the matrix for reflection from before, but matrix for reflecting across this plane we did before. So I'm going to reuse it, right? So we did this plane right here because we were talking about linear transformations and we derived that, but I'm just going to reuse it, okay? So this is like what we do is matrix for reflecting across this plane is the matrix for reflecting the normal to the plane is equal to, right? This is 1, 0, 2 is the normal to the plane. So we say reflection 1, 0, 2 perpendicular to the normal, right? It's perpendicular to the perpendicular, which means it's the plane. Okay, so reflecting, okay, perpendicular to the normal, and that gave us 1 over 5, 3, 0, minus 4. You can look up in your notes when we did this before. 0, 5, 0, minus 4, 0, minus 3. Just going to save us some time. I'm reusing an old thing. Otherwise, we'd have to go through and derive that matrix for reflection, which is fine. You know, we would do that. Okay, this was all set up, right? We were shifting our world. We're reusing an old matrix. Otherwise, we need to find out what that matrix for reflection is. Okay, so now let's actually go ahead and do our transformation. And I'll write down the different pieces of it. All right. Organized here. Okay, so our next step, right? The transformation goes like this. Okay, so what I do is I've got my matrix for reflection. Let me write it down again. 3, 0, minus 4, 0, 5, 0, minus 4, 0, minus 3. Now, what I need to do is I've got my origin point, my center for my sphere is at the origin, 0, 0, 0. I'll write down what these things are, 0, 0, 0. Now, this is the transformation. I'm moving, because I'm transforming, I'm moving my axis by subtracting it, right? To move my plane down, I have to, like, here's the sphere, here's the plane, and I have to move the plane down, but I have to move the sphere too, so they remain proportionally distant from each other. So when I move the sphere down, I'm moving the plane. When I move the plane down, I move the sphere too, so I can reflect across it. So this is moving the center of the sphere accordingly. I do the transformation, and I'm going to put this way out here, and then I have to shift our world back by adding back that same amount. So let's write down what these pieces are. So this right here, so this is reflecting across the plane. That would be x plus 2z equals 0, right? This is our plane that goes to the origin. Plane goes through origin. Here, that's this one. Okay. Now, this is moving the center of our sphere, moving, like we moved our plane, we're moving the center of our sphere, moving center of the sphere down to accommodate how we moved the plane to be at the origin, right? Because the plane didn't go through the origin, but now it does, right? So this is what we do. And then we'll do this one in purple. Here. And then we shift our world back. Back to its original location. So the order that we do this in is like this. I do this one first, I do my transformation, and then I move things back into place. Okay, so watch your order of things. Okay, so let's go ahead. I'm gonna do this part out. Okay, I'm gonna do this part first. So 0 minus 0 gives me a 0. 0 minus 0 gives me a 0. 0 minus 2 gives me a minus 2. I need to multiply that by my reflection, by my reflection matrix. So that's going to look like this. Get your 1/5. Okay. So remember how we do this, right? So this goes, this is going to equal 2. Let's just check. So this is a 3 by 3. This is a 3 by 1. The inner dimensions agree. The outer dimensions tell me my answer is going to be a 3 by 1. So I'll multiply the 1/5 later. And I'm going to get a 3 by 1. So this is going to be 3 times 0 plus 0 times 0 plus a minus 4 times a minus 2 gives me an 8. 0 times 0 plus 5 times 0 plus 0 times minus 2 gives me a 0. Minus 4 times 0 plus 0 times 0 plus minus 3 times minus 2 gives me a positive 6. Okay, so now I have 8/5, 0, and 6/5. Okay, think like that. Now I have to add that to shift my world back to 0, 0, 2. So I've just, this changes it, this moves it down so that it's reoriented in its origin. And I'm going to do my transformation, which gives me this. And now I have to shift my world back into place. Plus 0, 0, 2. Right? So 8/5 plus 0 is 8/5. 0 plus 0. 6/5 plus 2. So 2 is equal to 10/5, right? The common denominator. 6 plus 10, 16/5. Okay, so this is the new center of my circle, of my sphere. New center of sphere after being reflected in the plane, x plus 2z equals 4. Okay, so my center of sphere looks like this. 8/5, which is like 1.5 roughly, right? 0, 16/5, which is like 3.1, right? So this is the new center of my sphere. So if I were to write out a sphere equation, it's going to look like this. X minus 8/5 quantity squared plus y minus 0 quantity squared plus z minus 16/5 quantity squared equals, it still has the same radius. The radius doesn't change. Okay, we're not doing a scale on this. Okay, this is an affine. This is my new equation. Okay, so let's draw it out just so you can visualize. Here's my x-axis. Here's my y-axis. Here's my z. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so I'll draw my original circle. I'll draw that in blue. My original sphere. So it's got a 1 unit. It's going to look roughly like this. It's centered at the origin. Okay. My sphere, my plane, it's kind of like x and z. It's kind of like this. I'm not drawing it very well, but it's basically just in the xz plane. Okay, here's my plane. And that's a real rough sketch. There's our plane. Okay. And then our reflected, right? We're going to reflect it. So 8/5. I'm going 8/5 in my X direction. So I'm going to go almost 2. I'm going to go 0 in my Y. And I'm going to go just a little bit more than 3 in my Z. So my new center is right there. Okay. So my sphere now looks like, and there's my radius. Radius. Okay. And this is reflected sphere, original sphere. Okay. Just to give you a rough idea of what it looks like. Okay. Let you guys finish drawing that and writing it out, and then we'll try our next example, which is finding the projection of the line segment in the plane. Like I said, I'll post these later. All right. So example 2. Find the projection of the line segment from 0, 0, 0 to 1, 0, minus 1 in the plane. Y minus 3z equals 3. Okay. So we're going to do the same thing that we did before. I need to check if the plane goes through the origin, right? So I need to check if 0, 0, 0 is a point on the plane. I'm going to plug in 0 for X, 0 for Y, 0 for Z, and I'm going to get 0 equals 3. No. Okay, so the plane does not go through the origin. No. Therefore, our transform is affine. Good first check. When you're doing stuff in your game, have a check. You've got a subroutine. Is this linear or is this affine? What's going to happen? Does this thing, this line, this plane, this whatever, contain the point 0, 0, 0? It's going to tell you a lot right away. Does it go through the origin? Okay. So now we're transforming a line segment. A line segment is a point and it's just a line connecting those 2 points. So what we're going to do is we're going to transform point 1, right? And we're going to transform point 2, and then we're going to connect them again. Okay. So we will transform each point of our line segment. Okay. Which means I'm going to take 0, 0, 0, and I'm going to write it as a column vector. And remember 1, 0, minus 1 as a column vector. Okay. Of each point. Okay. All right. Okay, so we need to find a point on the plane. We know it doesn't contain the origin. So let's see, find a point on the plane. Which point you use is arbitrary. Okay, like I said, I tend to like to use things with zeros. It's easier. So I've got the point y minus 3z equals 3. Okay, so I've got x equals 0, y equals 0, which is going to give me minus 3z equals 3. I divide by a minus 3. Z is going to be equal to minus 1. Okay, so my point is going to be 0, 0, minus 1. That's going to help me determine, right, what I'm going to be doing. I'm going to be shifting my origin by this amount. Okay, I'm just going to write it in a different color. I'll write it in green. That we could have chosen other points. I could have chosen any. Chosen x equals 0, z equals 0, and then y equals 3, right? I mean, it's going to look like that would be 0, 3, 0. That would have been a point I could use, okay? Or any or any x value, right? Because basically x, isn't included on this. Basically all x values, all possible x values will work on here. So I could have chosen, 10, zeros. I mean, like whatever. I mean, I just could have chosen some kind of any X value. So it's arbitrary. Like I said, I tend to like to use things with a lot of zeros in it. It makes the math easier. I don't have to suffer. So be careful when you're choosing your values, but it's arbitrary. So I'll write any point on the plane will work. Okay. All right. So our next step, we have to find the projection matrix onto the plane. And I'm going to just write as a little note that we're just going to pretend that our plane goes through the origin, as though plane goes through origin. It's the same process because we're going to shift it up to the origin. That doesn't change the basic nature of the plane, okay? Because we're working with the normal to the plane, right? Remember when we do this. So the normal to our plane is 0 for X, 1 for Y, and -3 for Z. That's our normal. So when I look, I'm going to look for a projection, right? That's perpendicular to that normal. Perpendicular to the perpendicular means it's the plane. We're projecting onto the plane. So remember, our formula is the identity matrix minus our projection onto our normal. So this thing here, this is the projection onto our normal. We did that before, but we have to start off with that and then subtract it from our identity matrix, and that'll give us the projection onto the plane. This is like or vector math, right? We're projecting onto the normal, and I need to find the orthogonal to the normal, and that's going to give me stuff on the plane. Okay, so let's do this part first. 0, 1, -2. So I'm going to project onto the normal. That's this part right there. So how I do that is I do the normal times the normal transpose. Right, so this is normal transpose divided by normal dot normal. 0, 1, -3 dot product with itself. Okay, so remember, this is a 3 by 1, this is a 1 by 3. This I'm going to give you a 3 by 3 matrix. So this is going to look like 0, 0, 0, 0, 1, -3, 0, -3, 9. That's a 0. And that's being divided by 0 plus 1 plus 9. That's being divided by 10. So I can draw this out. 1/10, 0, 0, 0. So that's our projection onto the normal. I need to subtract that from my identity in order to get the projection onto the plane, right? So the projection to our plane is our identity 1, 0, 0, 0, 0, 0, 1 minus this thing here. I'm going to distribute the 1/10 into there because I have to do that so I can do addition with fractions. So 0, 0, 0, 0, 1/10 minus 3/10, 0 minus 3/10, 9/10. It's going to look like this. 1 minus 0, 0 minus 0, 0 minus 0, 0 minus 0, 1 minus 1/10. 1 is 10/10. 10/10 minus 1/10 is 9/10. 0 minus a minus makes it positive. 0 minus 0. 0 minus a minus makes it positive. 1 minus 9/10. 10/10 minus 9/10 gives me 1/10. 0. So this is our projecting onto the plane matrix. This is the thing that I need to project onto the plane. Let me write that down in a different color. Matrix for projecting onto the plane, which was given by y minus 3z equals 3. So this is with normal equal to 0, 1, -3. So it looks like this, right? I've got a plane. This is y minus 3z equals 3. You guys can't see what I'm writing. Y minus 3z equals 3. And this has a normal equals 0, 1, minus 3. Okay, so we're going to project onto this plane here. Okay, and this is the matrix that's going to allow us to do that. Okay, so we've done all our setup, right? Now I have to do the transform where I shift the world, transform, shift it back. Okay. All right, so step 5, transformation. Like this, right? I'm going to do it on end point 0, 0, 0. Remember, we have to do it on both endpoints. So I'm going to do it on that endpoint first. So I'm going to, this is my matrix for projection onto the plane. 1, 0, 0, 9 tenths, 3 tenths, 0, 3 tenths, 1 tenth. This is what we just figured out, right, in the previous step. Times 0, 0, 0, and I have to shift this point by this amount. Remember, this is the point that we figured out before. And then later I have to shift the world back. 0, 0, minus 1. That's just shifting the world back. Okay, that's why I put it way off to the side so I don't get confused. This is my first step. I do this one first. I do this one second. And I do this one third. Okay, in terms of order. All right, so let's go ahead and do it. So this is going to be 0 minus 0. 0 minus 0. 0 minus a minus 1 becomes positive 1 times 0, 3 tenths, 1 tenth. 0, 9 tenths, 3 tenths, 1, 0, 0. All right, let's go ahead and do it. So that's going to look like 1 times 0 plus 0 times 0 plus 0 times 1. 0 times 0 plus 9 times 0 plus 3 tenths times 1. Doing my matrix multiplication. This row times this column. 0 times 0, 3 tenths times 0, 1 tenth times 1, 1 tenth. Okay, plus 0, 0, minus 1. You have to shift the world back. Okay, so I'm going to get 0 minus 0 plus 0, 3 tenths plus 0, 1 tenth plus a minus 1. Minus 1 is 10 tenths. So 1 tenth minus 1 tenth, minus 10 tenths is minus a 9 tenths. So this point 0, 0, 0 is now, let's write it down like this. 0, 0, 0 is now 0, 3 tenths minus 9 tenths. Okay, we've transformed, we've projected it onto the plane. All right, I'm going to do the other one. Endpoint 1, 0, minus 1. Okay, you do the same thing. So we're going to set up our transformation matrix. 1, 0, 0, 0, 9 tenths, 3 tenths, 0, 3 tenths, 1 tenth. And now I have to take my 0.1, 0, minus 1. And I have to subtract. And then I have to add it back in. Okay, so this is going to be 1 minus 0, 0 minus 0, minus 1 minus a minus 1. So minus 1 plus 1 is 0. Okay, now I get to multiply the matrices out. Okay, so it's going to look like this. 1 times 1 plus 0 times 0 plus 0 times 0. 0, 0, 0, 0, 0, 0. Plus 0, 0, minus 1. It's equal to 1, 0, minus 1. Ooh, it didn't change. Let's take a look at that. That's okay, right? So 1, 0, minus 1 1, 0, -1. It didn't change, right? And it didn't change because this is actually a point that's already on the plane. Right, the point's actually already there. I don't need to project it because the point's actually on the plane already. It's kind of we're tricking you a little bit there. It's unfortunate. Okay, so now, right, our line segment, right, our projected line segment goes from, okay, remember this is, I need a vector, which is going to be terminal minus initial, terminal point minus initial point. So I'm going to go from my origin, which is now 0, 3/10 minus 9/10 to this point here, 1, 0, -1. So that means my terminal point is 1, 0, -1 minus 0, 3/10 minus 9/10. And that's going to give me a vector equal to 1 minus 3/10 and minus 1/10. Right, this is minus 10/10 plus 9/10 gives me minus 1/10. So that's my displacement vector right there, which gives me my line segment is going to be my initial point, which is 0, 3/10. This is my initial point plus t times my vector 1. This is like chapter 1 stuff. And then I have to restrict, it's a line segment, so I have to restrict my t be between 0 and 1. Don't forget the restriction on the t because it's a line segment. Okay, so this is the line segment that was projected onto our plane. Okay, the line segment that wasn't projected onto our plane is a line segment going from 0, 0, 0 to 1, 0, -1. Okay, phew, there's a lot of stuff. Chapter 2.4, part 2, which is affine transformations. Okay, I'll let you guys finish writing that down. And then what I'm going to do is I will take a look at our classwork. We had a couple of classwork problems that were about affine transformations. I think one of them, at least for chapter 2.4, I'll just start working my way through that here so that you guys can see what that looks like. And then when we get to other affine problems, you guys will be able to see what that is. I'm going to scan these in later and then post them up on our website so you guys can have it. All right. Remember I said, we'll come back to it, and then we didn't because I forgot. Okay, so this is classwork chapter 2.4, and I'm doing question 3, which is an affine transformation. Okay, you guys are welcome to watch. Like I said, I'm recording it. I'll post the recording later, and then don't forget the classwork stuff I'm going to collect. I'll collect at a different point. Okay, so affine transformation. So we've got this point, y equals x plus 1. So I'm going to graph this out. My line goes like this. So the line does not go through the origin, right? We can see that right there. And I need to project the point 1, 5. I want to reflect the point across this line here. So I need to be able to figure out what that's going to look like. All right, so I need to find a point on the line. I'm going to do x equals 0, y equals 1. That's a good point on the line. My reflection. Okay, and just my vector. The vector on the line is going to be equal to 1, 1. Okay. Yep. And then that's the vector on the line. That's not the vector perpendicular to the line. We'll deal with that later. All right. So let's see. This is going to be 2 times my projection matrix is 1, 1, 1, 1. Okay. When I go to create this, minus 1, 0, 0, 1, So this is just my reflection matrix. This is going to be, and this is 2 times, oh yeah, this is 2 times, and this is like 1. 2 times 1/2. So that just becomes 1 minus 1. That's a 0. 1 minus 2. 1, 0. Okay, so that's my reflection matrix. So now I'm going to do my shifts. I'm going to go 0, 1, 1, 0. Right, and that makes sense, right? Because it's I'm flipping my x and my y. If you think about what that's going to be. So my I'm taking the point 1, 5, and I need to shift it by the point that we figured out on the line. Do the transformation, and then I have to add that point back. Okay, so I put this way off to the side, so I'm not tempted to add it back in and then do the transform. So I keep my order of operations right. It'll be 0, 1, 1, 0 times 1 minus 0, 5 minus 1, 4. So this is going to be, forget that bit. So this is going to be 4, 1 plus 0, 1. This comes out to be 4, 2. So our point, our reflected point is 4, 2. I'm going to go 1, 2, 3, 4, up 2. And it's in the right ballpark. Look, I mean, it even looks symmetrical, right? Guys, anybody have questions on like homework problems or stuff you want to ask me while we're here? If not, then we can leave early. I needed to cover 2.4 part 2. And then we'll come back to the other chapters, 2.5, 2.6, when we meet again tomorrow. I want to just confirm something about our times. So tomorrow, and yeah, so tomorrow we'll finish up chapter 2.5, 2.6. 2.6 we have handedness to talk about, and then we can just keep practicing stuff for that. Don't forget we have a quiz on Monday. The Monday quiz will be on chapter 2.3 and 2.4. Okay, and all that stuff like the classwork, this classwork, and then homework stuff for 2.3 and 2.4 will be due. I also need some kind of project description by Monday. Some of you guys have already passed it in, but I'll need your project descriptions by Monday also. Okay, keep that in mind. If nobody has any other questions, then we can just end class. What do you guys think? Okay, I'll take that as a yes. All right, you guys have a great day, and I'll talk to you guys later. Bye.
Thank you.
Bye.